Hi, I'm Qian Yang from Carnegie Mellon University. I'm presenting the poster about how to bridging machine learning and real-world complexities through interaction design. So there are basically two parts of this problem. One is input. How can we take inputs from users that can serve as a ready source for machine learning trainings? On the other hand, how the output of machine learning can be made most usable and practical for the users in real-world scenarios. So I have two case studies to support my study. The first one is about the output side. I did a field study about how clinicians, specifically cardiologists and surgeons, make artificial heart implantation decisions. And I talk about many barriers, including their attitudinal barriers, their social structures, information that they really need, and how these barriers could potentially prevent machine learning come to effect. And I discussed the design implications from this. And on the other hand, it's how can we design the interfaces that can collect data whose interaction traces can serve as a ready source for machine learning. So the basic idea is that interaction designers should think about machine learning opportunities when they plan and wireframe the interfaces. So machine learning can be practiced in the wild. And so this is a graph of how this interaction design trace can be. The designers should not only picture the baseline, the cold start status of the interfaces, but also think about how the interfaces can be adapted, how the interfaces can keep collecting labels even when the interactions are simplified. So this is the basic idea, and I hope to start a conversation about how interaction design can integrate better with machine learning and serve to the real world and bring out the power of machine learning in the real world.
Well, fantastic. Maybe a quick word about what does it change of doing machine learning in critical systems or safety systems? Because with medicines or
What do you mean by safety systems?
I mean, for heart implant patients, you're really not really fault tolerant, right? You want. So how do you deal with that? What do you see as the main issues?
You mean like specific designs we want to carry out? Okay. Yeah. So for the clinical decision support tool, we brings out four major barriers. For example, we found most of cardiologists and surgeons don't feel the necessity to use any data support, partly because they are confident in their own training and decisions. And also, they have a huge group of interns, fellows, nurse practitioners. Like the whole work structure is to support their decisions. And they find input from their colleagues is more trustworthy and actionable than a numeric prediction made by machine learning algorithms. So one of the implications we draw from this study, this finding, is to think of this tool not only as a decision support tool, but also as a training tool provided for mid-levels. So nurse practitioners or interns can look at this data. Maybe they would ask the cardiologist why what you said was different from what the algorithm is saying, and using this kind of educational conversation to impact the real results of the clinical decision support.